Hello, everybody. Good day. I hope that you're all doing well today. For this video, you will be learning all about enzymes and vitamins. Um, this is the first topic that you'll be having for the final terms. So, for this specific discussion, we will be tackling the following things. So, we will look into the general characteristics and structures of enzymes. We will also be able to learn nomenclature and classification of enzymes, their activity. We'll also look into enzyme inhibition, the medical implications of enzymes, characteristics of vitamins, and some types of vitamins, specifically water soluble and fat soluble vitamins. So these are the things that you'll be able to hopefully learn and appreciate at the end of this video discussion. So to start things off, let's look at the general characteristics of enzymes. Okay, so what are enzymes? When you hear the word enzyme, what comes to your mind first? Unsa yung inyong mahuna-hunaan whenever you hear the word enzyme? I know that this is no longer new to you. You've been introduced to this word over and over again in your past science subjects. So for you, what is or what are enzymes? I will give you some time to formulate your own description of enzymes. Okay, so enzymes, ang pinaka-main na function ni enzymes is that they are catalysts for biochemical reactions. Okay, they catalyzes reactions. Simply put, what enzymes do is that they speed up the occurrence and completion of a certain biochemical reaction. Okay, they catalyze it, and we say it catalyzes it. It speeds up. It furthers the completion of a certain biochemical reaction. So that is what enzymes do. Now, the thing about enzymes is that they are mainly proteins. Okay, so the most common enzymes are proteins. Okay, and so because they are proteins, they also exhibit or they also have the same properties, the same qualities as protein have. Because after all, again, enzymes are mostly proteins. Now, there are a lot of different enzymes in our body. Of course, due to the fact that for the um, well being of the body system, there is a lot of biochemical reactions involved in it, right? And for each of these biochemical reaction, kada isa ani nila nga mga reaction, and there's a lot of reactions, there are certain enzymes needed for the completion of these different reactions. Now, every cell in the body contains thousands of different enzymes. Take note, every cell. So if it's that many, right? Every cell in the human body contains thousands of different enzymes. Again, why is this so? Again, it's because almost all reaction in the cell, and there's a lot of reactions that occur in the cell, requires its own specific enzyme. Okay, moving on. Okay, so like what I've said to you earlier, enzymes cause cellular reactions to occur millions of times faster than uncatalyzed reactions. So, sa enzymes daw, because of the actions of these different enzymes, biochemical reactions can occur million times faster than those reaction na walay enzymes involved. So, what do you call this? Significant ang effect ni enzyme to these reactions. So think of it as turbo for a speeding race car. So enzymes kay more daw sila og mga turbo, right? Na they speed up race cars. Mas ipakusog nila ang dagan sa isa ka race car. So the same way as what enzymes do, they also speed up reaction 2 million times faster. So their effect is that significant. It's that heavy. Now, to continue, okay, the thing about enzymes though that you have to remember is that they are not consumed during the reaction, but merely help the reaction occur more rapidly. So, dili daw sila ma-consume when they catalyze a certain reaction. Okay, they just help the reaction occur more rapidly, but they are not consumed. Dili sila murag gasolina, for example, when we try to um, think of it as a speeding race car, they're not like gasoline na ma-consume as the car continues with its speed. Enzymes, on the other hand, are not consumed during their action. Okay, they just help the reaction occur more rapidly. Okay, like what I've said, enzymes are mainly proteins. And because they are proteins, or they are mainly proteins, enzymes also possess um, the same characteristics, the same properties. They're also subjected to the same na destructive mechanisms as proteins do. Okay? They undergo all the reactions of proteins. For example, denaturation. So enzymes can also denaturize. Okay? Um, if you can remember in our discussion on proteins, denaturation is the process or the disruption of a protein's folding. Okay, so since enzymes are proteins, mostly proteins, they can also undergo denaturation. Now, pH and temperature may affect enzyme activity. So, for example, a person suffering from high fever runs the risk of having enzymes denatured. After all, high temperatures can cause unwanted effects to proteins and enzymes. They can denature these proteins and enzymes. Therefore, ang tao na taas og hilana, taas ang iya ang temperature, may have risks of having their proteins and enzymes denatured as their temperature continues um, to rise higher and higher. Which is why um, common nga habit nato when magtaas ang temperature sa isa ka tawo is mag-take ta og paracetamol, right? To counter or to help lower down temperatures. Because after all, high temperatures can cause unpleasant nga mga effects to our enzymes and proteins. Okay, another action that could also ruin the quality of enzyme activity has something to do with its handling. So, for example, a chemist should be very careful in handling enzymes to avoid the loss of their activity, for even vigorous shaking may destroy enzyme activity. So, these are just examples of how enzyme activity may be disrupted, may be ruined due to various factors. Okay, now enzymes are classified as either simple enzymes and conjugated enzymes. Now, what is the difference between the two? It's simple. For simple enzymes, these are enzymes that are composed only of proteins, okay, or amino acid chains. So, simple enzymes daw are those enzymes that they are purely proteins. They are simply proteins. They are composed of amino acid chains. After all, amino acids are what makes up proteins, right? Now, the conjugated enzymes, on the other hand, are those enzymes nga composed of a protein nga part and a non-protein part. Okay, so lahi siya to that of a simple enzyme because a conjugated enzyme, aside from having a protein part, naa siya'y non-protein pod na part. So that is just the difference between simple and conjugated enzymes. Again, simple, composed purely of proteins; conjugated, composed of protein and a non-protein part. Okay. Now, the protein and the non-protein parts of a conjugated enzymes can also be referred to as apoenzyme and cofactor. Okay? Apoenzyme is ang protein nga part sa conjugated enzyme. And pag siya lang alone, apoenzyme is inactive. Why is it inactive? It needs the additional properties of the non-protein part, which here we refer to as cofactor, to become active. Okay, again, si apoenzyme siya ang protein nga part sa conjugated enzyme. Cofactor, on the other hand, is the non-protein part of a conjugated enzyme. Now, the combination of apoenzyme, the protein part, and cofactor, the non-protein part, makes up the term we call hollow enzyme. So, what is a hollow enzyme and how is it different to that of conjugated enzyme? So, more, think of it as like another term lang for conjugated enzymes. Okay? The term hollow enzyme is used to designate a biochemically active conjugated enzyme. Okay? So, ang hollow enzyme daw gud nga term is just used to denote a biochemically active nga conjugated enzyme. It's now active because of the added actions of the apoenzyme and the cofactor. Okay, now why do apoenzymes need cofactors? The thing about this is that cofactors provide additional chemically reactive functional groups besides those present in the amino acid chains of apoenzymes. Diba? If you can remember, during our discussion on proteins, amino acids are the building blocks of proteins, right? And the thing about amino acids is that ginadistinguish sila using the different R side chains attached to them, right? Now, cofactors provide additional chemically reactive nga mga functional groups aside sa R side chains that are already existing in the amino acid chains. Okay, which is why cofactors are needed for the entire conjugated enzyme to be biochemically active. Okay. We have two categories of cofactors. Remember, cofactors is ang non-protein na part. So we have two categories for them. We have simple metal ions and small organic molecules. Okay. Now, what is the difference between these two types of cofactors? Let's start first with simple metal ions. Okay, simple metal ions include zinc, magnesium, iron, and copper. Now, all of these must be supplied to the human body through dietary intake, and they are needed in trace amounts or small amounts. Okay, these are the simple metal ions cofactor. Again, the zinc, magnesium, iron, and copper. Now, the second category of cofactors are the small organic molecules, which are further collectively known as coenzymes. Okay? Don't be confused with the terms. Coenzymes are the organic cofactors. Ano lang, think of it that way. Now, small organic molecules are synthesized in the human body using building blocks obtained from other nutrients. So it's different to that of the metal ions in the way that organic molecules can be synthesized in the human body using ingredients that are obtained from other nutrients. Okay? So that is one difference between the two. Simple metal ions supplied to the human body through Dietary intake, small organic molecules or coenzymes are synthesized using ingredients obtained from other nutrients. Now, these small organic molecules are most often existing as B vitamins or a derivative of B vitamin. Now, when we say derivative, it is a compound that is derived from a similar compound by a chemical reaction. So, small organic molecules, these are composed primarily or mainly of B vitamins or their derivatives. Now, to continue, a cofactor may be permanently or temporarily bonded to the amino acid portion of the conjugated enzyme. Okay? Now, permanently bonded via covalent bond to the amino acid portion of an enzyme. Example of these, we have the coenzyme FAD or the flavine adenine dinucleotide, um, which has riboflavin, which is a B vitamin. Okay? Now, cofactors can also be temporarily bonded. So, pwede siya nga dili siya permanently bonded to the amino acid portion of the enzyme. And mabond lang siya at the time it is needed, and then it is again released after the reaction has occurred. Example of this is the coenzyme NAD+, or the nicotinamide adenine dinucleotide, which has niacin, a B vitamin also. Again, cofactors, which is the non-protein again nga part of the conjugated enzyme, pwede siya nga permanente siya bonded to the amino acid portion or pwede po siya nga temporarily bonded lang siya to the amino acid portion. And ayan na siya mo bond pag kailangan siya sa reaction and then ma-release ra pud siya balik, ma-separate ra pud siya balik from the amino acid portion after the reaction has occurred. Okay. Now, breaking of the covalent bond deactivates the enzyme. So, in temporary bonding, pag ma-break na ang bond between the amino acid portion and the cofactor, ma-deactivate ug balik ang entire na enzyme. Okay, moving on. Let's now go to nomenclature and classification of enzymes. Okay, how do we name enzymes and how do we classify them? Now, enzymes are most commonly named by providing information about the function rather than the structure of the enzyme. Okay? Unlike daw kuno other biomolecules that we have discussed before, nga ang iyang classification and ang iyahang naming depends on the structure of those certain biomolecules, lahi ang sa enzymes because in providing or in naming them, dito ta mag-base sa iya ang function rather than its structure. Now, in enzyme nomenclature, we consider the following focal points: the type of reaction catalyzed and ang substrate nga the enzyme is working on or acting on. Okay. Substrate, substance upon which the enzyme acts on. For example, in the fermentation process, sugar is converted to alcohol. Now, in this particular example, sugar is the substrate. Okay, now let's look at the three important aspects of the naming process of enzymes. Okay, we have 3 points here. First is that ini siya very often na makita nato when we encounter enzymes. Ang ilaang mga pangalan, they almost always end with the suffix ase. For example, sucrase, nuclease, lipase, carbohydrates, what else? Every mga common nga mga words that ends with the suffix ase, okay, kana lang alone can already tell you that that molecule is an enzyme. Okay, when it ends with the suffix ase. Now, there are certain exceptions to this, though. For example, trypsin, chymotrypsin, and pepsin. Now, they do not end with the suffix ase. However, they are still enzymes. Now, the thing about these exceptions is that these enzymes are discovered earlier in time, and so they are firstly studied. Thereby, di wala sila ka-adapt sa name of more modern enzymes which has the suffix ase in its ending. Number two aspect of the naming process of enzymes. The type of reaction catalyzed by an enzyme is often used as a prefix. Okay, for example, if ang reaction nga gicatalyze ana nga enzyme is an oxidation reaction, the term oxidase is added in its name. Okay? Now, if you encounter the term hydrolase, then that is an enzyme that catalyzes a hydrolysis reaction. Okay? Transferase enzyme that is catalyzing a transfer reaction. So sa ilahang name pa lang alone, you can already infer, you can already tell the type of reaction nga makatalyze an nga certain enzyme. Now, third important aspect, the identity of the substrate is often used in addition to the type of reaction. Okay? Aside do sa type of reaction, ang identity of the substrate can also be used. For example, glucose oxidase. We know that oxidase involves an oxidation reaction, right? And specifically identify pag yun si substrate, which is the glucose. So in this note, this therefore involves the oxidation of glucose. Pyruvate carboxylase. This involves the addition of a carboxyl group. So, ang ihon lang ng tawon is the type of reaction as well as the identity of the substrate that is often included in the naming process of enzymes. Okay, more on the third point wherein the identity of the substrate is often used in addition to the type of reaction. We have here glucose oxidase. Okay, the oxidation of glucose. Pyruvate carboxylase, the addition of a carboxyl group, and succinate dehydrogenase, dehydrate, meaning it involves the removal of a hydrogen atom. Now, infrequently, the substance but not the reaction type is given, as in the names urease and lactase. So, in these examples, urease and lactase, gihatag ang identity ni substrate, but the reaction type is not given. Now, in these cases, the reaction involved is always the hydrolysis reaction. Okay? For example, urease, it is an enzyme that catalyzes the hydrolysis of urea. Lactase, an enzyme that catalyzes the hydrolysis of lactose. I think I have already introduced it to you during our discussion on carbohydrates, I think. For example, there's this time na for certain nga mga carbohydrates, ang enzyme nga needed to hydrolyze it is ano lang, based lang pod on its name. For example, sucrose. The enzyme needed to hydrolyze sucrose, sucrase, right? What else? Lactose, lactase, maltose, maltase. Okay, so pag When you encounter these words in the future, that can already tell you that these are enzymes that hydrolyzes these molecules or these substrates. And when we say hydrolysis, it involves the breaking down of these molecules or these substrates to their simpler components. Now let's have a practice exercise. Let's try predicting the enzyme function from the enzyme's name. Okay, so let's predict the function of the following enzymes. Let's start first with cellulase. Okay, so as you can see, the substrate is given, right? And it ends with the suffix "ase." So what do you think is the function of the enzyme cellulase? Okay, so the substrate is given, the reaction type is not. However, this is this therefore is an enzyme used to catalyze the hydrolysis of cellulose. How about sucrase? Very easy. I've already mentioned this earlier. Hydrolysis of sucrose. L-amino acid oxidase. Okay, both the substrate and the reaction type is given, right? Now, the reaction involved in here is oxidation reaction after the name oxidase here in the enzyme's identity. Now, oxidation reaction of L-amino acids. Okay, how about this one? Aspartate aminotransferase. Again, both the substrate and the reaction type is given. Now, the substrate is given, the reaction type is also specified, transferase. Okay, from its very name, it involves the transfer of a component from one molecule to another. This, therefore, is an enzyme used to catalyze the transfer of an amino group, aminotransferase, transfer of an amino group from the substrate, which is the aspartate, to a different molecule. Okay, aspartate aminotransferase, transfer of an amino group from aspartate to a different molecule. Okay. Lastly, for this video, this is just part one of my discussion on enzymes and vitamins. Now, we have here classes of enzymes, and we will be looking more into this on the part two of the video. Now, enzymes are grouped based on the types of reactions they catalyze, and we have six classes um, based on the type of reactions catalyzed. We have the following: oxidoreductases, reaction catalyzed, oxidation, and reduction reactions. Oxido, oxidation, reductases, reduction reactions. Transferases, transfer of a functional group from one molecule to another. Hydrolase, hydrolysis reactions. Number four, lysis, reactions involving the additional or removal of groups to form double bonds. Number five, isomerase, it involves isomerization reactions. And number six, ligases, these are enzymes that catalyzes reactions involving bond formation with the participation of ATP. So we will continue with the discussion on enzymes more on the second part of my video discussion, as well as the things here. We have yet to discuss a lot of things here. So we will continue with in the part two of my video discussion on enzymes and proteins. So you will be performing an activity on this as well as an assessment to assess the things that you have understood, hopefully understood from this video. Now, if you have any questions, you can always freely message me, okay, when there are things that you would want to clarify or things that you would want to ask me. So thank you very much for watching this video. I hope that you have learned and you have gained something from this. And again, feel free to reach out to me when you have clarifications or questions. Take care, everyone, and goodbye.